Welcome to this episode of Robert's Creative Chronicles. So today we'll be solving this example 1 on traces. So the scale we are going to use for these traces is half full scale. We are going to use a scale of 1:2, half full size. So we are going to use half full size scale. So let's draw the center line. So we are going to first draw the center line. So now this will be our XY line, XY. Then the distance from here to here is what? Is 88. So it will be 88. So it will be 88 divided by 2. That's what? That's 44. So we're going to measure 44 here. So from here, 10, 20, 30, 44. So this is 44. Then the distance from here it should be 12. But since it's half full scale, it's 6. So we're going to measure 6 here. But first let's draw a vertical line. These are projection lines. So on this line, we'll measure 6 here. So here will be 6. And here downward will be 50. Then here, so upward here will be 38. Then down here will be what? Will be 10. So then we'll join this. So here is what? Here is A1, B1, and here is what? A2, B2. Here is the elevation, here is the plan. Since this is first angle projection, so now we'll project this and we'll project this. Likewise here and here. So now we will now project the auxiliary views. From the plan, we will project an auxiliary elevation. So from this one, we're going to project from this point also. So now we will get another plane here. This will be a center line. So this plane will be what? This plane will be x1, y1. This is the plan. When we project this, we'll get an auxiliary elevation. So the dimension we're going to use here will be the dimension of the elevation, since this is an elevation also. So the dimension we're going to use here will be the dimension of this elevation, since this is an auxiliary elevation. So this is A2, here will be what? A3, and B4, B3. Since this is B2, here B3. And here is A2, here is A3. So now, this is the original XY plane. This is the original XY line. So we'll measure the dimension of this elevation, which is 32. So we'll come, this is B1. So we'll come to the point of B and we'll put the 32. This is 32. And on A is still on A. So you join it. So now, you know, this line is the line for B. So now here, instead of here, we'll write the B3 here. So now this is A3, B3. Just how here is A2, B2. So we can erase this from here. So this line is the true length of AB. And this, the angle here will be the true inclination to the horizontal plane. This is the horizontal plane. So the angle here is the true inclination to this horizontal plane. So let's project this to get the auxiliary plan. So now we can put the XY plane here. Here is X, so here now will become X2. Since this is X1, then here is now Y2. So on X, A is around X side. So here will be our A. So since we are projecting this elevation, we will get the auxiliary plan. You know, you project elevation to get plan, you project plan to get elevation, and vice versa. So since we are projecting this elevation, we are going to get auxiliary plan. So the auxiliary plan, the dimension we are going to use for this auxiliary plan will be the dimension of this plan, which is this. So our dimension is now this one. This is what? Is 4. So around A here will be 4. So make sure to know the side you are measuring. If it's A, put it at A side. If it's B, put it at B side. So this is X, you know, this is X and this is A. So this is X and this is A. So here will be what? Will be A4. And here, you know, B is on the line here. So, and this is now the line. So here will be what? B4. So we'll join this. So now this is also the true length of AB. And the angle here will be the true inclination to the vertical plane. This is the vertical plane. So the angle here is the true inclination to the vertical plane. And here is the true length of AB. So now remaining one more step. So now this elevation and plan, to get the horizontal and vertical trace, we project them. We will project them to touch this plane, this XY line. So this elevation, we are going to project it so that to touch this XY line. So we'll project it downward. It touches it here. Then we'll project it upward like this. When you project this line and where it touches this XY line, You are going to project it downwards, the point that touches it. So this point, you're going to project it downwards. You see? Then you're also going to project the plan. So we'll project the plan also. So where this one touches it, you know this projection is on the plan. So since this projection is on the plan, this one will be a horizontal trace. So I call it HT. This stands for horizontal trace. So the horizontal trace is on the plan. So the horizontal trace is always on the plan. And now to get the vertical trace, we're also going to project this to touch the XY line. So where it touches it, you project it up. So this projection, this dot where they meet, this is on the elevation. So this trace is on the elevation. So this is called the vertical trace since it's on the elevation. So vertical trace is always on the elevation and horizontal trace is always on the plan. So when you project these two lines and they touch the plane, when you project them upward or downward, where they meet, and if it's on the vertical, if it's on the elevation, that point is the vertical trace, and if that point's on the plan, it's called the horizontal trace. So now let's write some of the dimensions. So here will be called theta. Then here is what? It's also another angle. And note that this one is the auxiliary elevation, not auxiliary plan, and this one is the auxiliary plan, not auxiliary elevation, because you know that when you project this plan, you will get an elevation, not a plan. So this one is the auxiliary elevation and this one is the auxiliary plan. Because when we project this plan, we will get another elevation, which is called the auxiliary elevation. And when we project this elevation, we will get another plan, which is called the auxiliary plan. So this one is the auxiliary elevation and this one is the auxiliary plan. So all these other abbreviations like E, P, TL, all of their meanings are stated here. TL stands for true length, VT stands for vertical trace, HT stands for horizontal trace. This one stands for true inclination to HP. This one is the true inclination to VP. And HP and VP are the horizontal plane and the vertical plane. Then E is elevation, P is plan, then this one AP and AE. So here is it, and this symbol shows that it's first angle projection. And note this the true length of AB is 67 millimeter. So if you measure it here, you can see that it is 67 here. Likewise here also. You can see that it is also 67 here. So therefore, when you do this kind of solution, the true length here, AB, must be the same as the true length here. So the true length on the auxiliary elevation must be the same as the true length on the auxiliary prime. If these two lengths are not equal, you can see that mine is equal 67 and 67. If these two lengths are not equal, if these two lengths are not the same, that means there's an error in your drawing. So if these two lengths are not the same, that means there's an error. That means there's an error in your drawing. And here also, this one, this angle, this is 30. You can see it is 30 degrees. So this angle is the true inclination. So this angle is the true inclination to the horizontal plane. This is the horizontal plane and this is the vertical plane. So this angle here, which is 30 degrees, is the true inclination to the horizontal plane. And this one, you can see this is 20, 30, 37. So this one is the true inclination to the vertical plane. This is the vertical plane, this is the horizontal plane. So these two angles, they may or may not be the same. I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email written in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share, and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.